Hi and welcome back to Learn Python by Doing number 23. Now we're going to talk about set operations. So remember, we can do the same basic operations that we can do with mathematical sets because Python sets are representations of these mathematical structures. Okay, so remember last time we created our fruits list, which contains apples, watermelon, and grapes. And we created a set out of this list. And we created also another fruit set with, well, I have modified a little bit the elements. So these are the elements of the another fruit set. And well, if we print fruit set, we have apple, grapes, watermelon, and another fruit set has apple, grapes, lemon, mango, peach, pineapple, and watermelon. Okay, so first we're going to see if, for example, the fruit set is a subset of the another fruit set. So we say fruit set dot is subset of another fruit set, and this will return true because our fruit set have apple, grapes, watermelon, and another fruit set also has apple, grapes, and watermelon. So this is a subset. Now let's check if it is a superset. So we call this method is superset, and it is false because this is not a superset of this. But if we change the roles, so saying another fruit set is superset of the fruit set, then the result is clearly true because this is obviously a superset of this fruit set. Okay, so now let's go to the union. So this is the Venn diagram for the union. And let's see, we can use this operator, which is a vertical bar, and call another fruit set. And this will be the result. Apple, grapes, lemon, mango, peach, pineapple, and watermelon. But actually we can do the same operation, but using this method, which is simply the method union. Okay, so another fruit set, and we have the same result. Okay, so this is clearer because maybe you don't know, or the people who is seeing your code don't know what this vertical bar means, but they can know that you are trying to do the union of sets if you explicitly say, hey, I'm doing union here. Okay, but if we print fruit set, then it is unchanged. And if we call or print the another fruit set, then it is also unchanged. So these two operations here do not change the original sets. If you want to change the original set, then you must do the following. You must use this vertical bar with the equal sign, another fruit set, and now you can print again the fruits set, and as you can see now it is updated. So remember, we had only apple, grapes, watermelon. Now it has apple, grapes, lemon, mango, peach, pineapple, and watermelon. We can also do this with the update method. So remember, we have already used this update method, and well, the result will be the same. So let's actually recreate these things here so we can go with the intersection. Okay, so this is the Venn diagram for the intersection, and for it we're going to use fruit set, and we're going to use this symbol here, and we are going to call the another fruit set, and the result is going to be the same because A is a subset, or fruit set is a subset of another fruit set, so the intersection will be a fruit set again. We can do this also explicitly with the intersection method. So fruit set intersect. Actually, let's do yeah, fruit set, that intersection, another fruit set. And well, it's the same result, but again, if we call fruit set, and let's print them to save space, and let's print also another fruit set, then they are unchanged. So if you want to modify the original set, then you have to use again this with the equal sign, another fruit set. But well, it's going to be the same set, so let's maybe let's use another. Let's put here, I don't know, what could I put here? Banana. So now this result will be different, so let's see. Now we have banana and the intersection should be different. So fruit set, it's going to be fruit set, watermelon, apple, grapes, and watermelon. So banana is out because banana is not present in another fruit set. Okay, so you could have done this also with intersection update, another fruit set, and let's see, fruit set again, it's apple, grapes, and watermelon. So banana is out because banana is not present here, so it's not in the intersection. Okay, now we can do the difference. So I hope you are seeing now the pattern here. So with the difference, we say fruit set minus another fruit set, and it's going to be an empty set. Okay, why? Because well, we updated here, so we have to actually recreate these things here. Okay, so now it will be banana here, I think. So yeah, now this is going to have only banana because banana is the only element that is not present in another fruits set. Again, we can do this by simply saying difference with another fruit set, and the result is going to be banana. Again, if you want to modify this, because this is creating new sets, then you have to use the following thing. You have to say minus equal another fruit set. So now let's check fruit set, banana, or you can simply use difference update with another fruit set. Okay, and now let's see fruit set. It's still the same result, banana. And finally, we have here the symmetric difference. So let's actually recreate these things here. And now, let's see. Here we can use this operator here. Fruit set, another fruit set, and it's going to return these elements. This is the Venn diagram describing that operation, but we can also do with symmetric difference, another fruit set, and again the same result. And if you want to remember, update the fruit set, then you can do something like this, another fruit set. So let's see now, fruit set contains this, or you can simply say symmetric difference update another fruit set. Okay, so now this changed a little bit, okay, because we modified the fruit set before, but it's okay. You can use symmetric difference update or this one. Okay, so those are the operations you can make with sets. And well, I hope you liked this video. See you in the next one.